Okay, so this is Caleb Kimbrough and Andre Hetman. This is our final project for Engineering Electronics. This is our circuit. We have 15 volts going in, negative and positive, to power the op amps. You can see our schematic for the parts and values we used. We have our square wave set up to input a plus and minus 5 volt square wave with 1 hertz frequency. It goes in over here, and then this is our output. So you can see the yellow channel 1 is our is the input function, and when you look at the scaling, it's got 2 volts, so is the scaling. So that's 5 and that's minus 5. Frequency overall is takes one second to complete 1 cycle. So when we put the oscilloscope to read channel 2 on the first op amp, you can see the gain is half on that op amp, so it just about cuts the peak in half. Let me see, make sure that's centered. Okay, centered on 0. So you can see it basically cuts our amplitude of 5 volts down to 2.5 volts, and you can see the peak to peak is 5.4, and the peak to peak for the yellow is about 10.7, so that's right. And we take the oscilloscope to read the second op amp, which is our integrator, and you can see it's integrating the values. Positive is it's also inverted, so it's going to give a negative slope for a positive value, positive slope for a negative value. It's basically integrating our signal. And then the summer, the last one, we've got the outputs going through these 2 resistors of the same value, running down through here and into our third op amp, which just should sum the values. And you can see we have basically what becomes the sum, the value of the first one plus the value of the second one gives us a slope up and down for all those. And that's our project.